Welcome to Farm Science Review 2025. Today we're going to be talking about BaselineRx with Agronomy 365 and BW Fusion. So what BaselineRx is a soil test that is creating zones based on topography, water holding capacity, and color of the soil. So what we've got here is a 100-acre field that shows the different colors as your different zones. Most fields end up being a 5-zone field, and we'll pull a sample from each one of those zones to build our recommendations. So the real key to this process is the soil test that's behind it. We call that the indicator max. It's done in Alpena, South Dakota at Next Level Labs. So your normal soil test is going to have 12 to 14 metrics on it. This soil test actually has over 75 metrics on it. So we're not just testing for nitrogen, we're testing for different forms of nitrogen and different ways that nitrogen is going to be released from the soil. So we'll start here at the top. We've got organic matter, pH, buffer pH, just like we would have on any soil test. Then we get into something called WEOC over CEC. WEOC over CEC is a very important metric for us to look at so we can understand the amount of carbon in our soil versus our nutrient holding capacity of the soil. The higher the WEOC over CEC, the better we are at the end of the day. Then we get into HT3. That's our carbon burst. Many of you may be familiar with it as the Haney test. So we're really measuring soil health and microbial activity with the HT3 test. We get into VAST, which VAST is more of a soil structure test that we look at to determine the flocculation of your soil. And then your bacteria to fungi ratio, the closer that gets to 1, the better off we are. So right here we're at a 0.5, so we're going to have a little bit lower overall soil health score than we would if we got that up to a 0.7. Getting into nitrogen, one of the important things that we look at with nitrogen is your SLAN. So that's really going to predict how much nitrogen you have available at the in season or at the end of the year. If we get a SLAN over 70, we're able to bypass a lot of these later nitrogen applications because our soil is going to be able to release that naturally, and we don't need to make that extra application. We've got C-to-N ratio, our WEON, which is water exchangeable organic nitrogen. That's going to be nitrogen that's actually available to your plants right away. Here's your WEOC number, water exchangeable organic carbon, which we talked about up here in the biology section. And we can get down to our total estimated end release. So we're looking at 50 pounds of nitrogen that's going to come from that soil that we can count on without having to apply it. Moving on, we'll go to phosphorus. So what's really exciting about this indicator max soil test is that we measure the total amount of phosphorus, total amount of potassium that we have in our soils with an x-ray test. So this soil actually has 1,350 pounds total of phosphorus in it. We're able to use that to monitor and make sure we're not robbing that soil of nutrition. We're actually just cycling those nutrients and keeping our soil test levels up. Where a Bray, a Malik, or an Olsen can fluctuate year to year based on moisture, your total amount is not going to fluctuate. Then we get down to our H3AP. H3A is the nutrition that is available to your plant. It's in the plant available form. So we already have 15.8 pounds available to our plant in this scenario. Potassium after that, we've got that x-ray test again. It looks like we've got 29,000 pounds of potassium in your soil. So this was the biggest eye-opening thing for me when I did my first indicator max soil test, was how many pounds of these nutrients we actually had in our soil. We just needed to release them. So you're looking at a K of 92, and you're like, wow, that seems really low. But you're looking, you've got 29,000 pounds available in your soil to release. So working on the release of that soil, getting our HT3 up, and getting this H3AK up, we can really get a lot more potassium into our plants. And then we work through the same thing with calcium. We look at total, we look at H3A, your base saturation cal, which is 78.6, which is pretty high on this example here. So we get on the back side of the page here. We look at aluminum and iron. Iron for actually plant food, and we're looking at aluminum to make sure we stay below toxic levels. So that's an important thing to look at. And looking at this soil test, we've got 112,000 pounds of aluminum in these soils. It's hard to believe that there's that much aluminum or any nutrient that we're not actually applying. We get down into the micros. We don't spend a lot of time on micros because we're not trying to build those in the soil. We understand that those are going to be a usable or leachable thing that's going to be really hard to build and really expensive to build. So we try to feed that plant during the year the things that it needs. But we're looking at zinc, manganese, copper, sulfur, boron, and chloride in that. So we just things we look at. Magnesium, if you're here in central Ohio, a lot of us have high mag soils that we fight. Causes us a lot of crusting and drying out problems. So you've got your measurement of magnesium, your H3A score, which is going to be plant available, base saturation, and then your K-mag ratio, which can be really important in our high mag soils. We've got to make sure that our K-mag ratio doesn't get too far out of balance because with all the magnesium on the colloid, we have a hard time holding potassium there and keeping it in the available form. We get down into base saturations and then our recommendations. So with our recommendations, you're going to get an Agronomy 365 recommendation in your standard like you get in any other soil lab. And comparing those can be very interesting because we take into account all of the efficiency factors of your soil, which may raise or lower the amount of fertilizer that you need to put on. And expecting growers to understand a lot of these soil metrics, or even me understanding all these soil metrics, can be really tough. So the easiest thing to look at is the gauges here at the bottom. You know, we've got one for nitrogen, phosphorus, potassium, and calcium. The higher you are on that gauge, the better you're doing with that nutrient. So we see here that nitrogen and potassium are down in the 2s, so we would really focus on those 2 nutrients, improving their availability in the soils, either with product applications or with practice changes, doing something different to release those nutrients. So we have our recommendations here. Here we get into Ferticast, where this is where we put in what applications we have available. If you have a side dress bar, you have Y drops, you're putting everything on with the planter. We put those in. We put in what products we want to use. So if you're a 32 guy, a 28 guy, you like to spread dry AMS, we put all those products in. It spits out this application plan and gives you what you actually need to put on. And there are more efficiency factors that come with those different things. If you're doing them, putting all your nutrients on in the fall, you're going to have to apply more nutrients to account for tie-up than if you're putting things on in the spring. And that third recommendation comes in here at the bottom of this slide here. It also recommends what BW Fusion products can also help with efficiency. You can toggle those on and off and see how that affects your efficiencies on the recommendation side. But the biggest thing at the bottom here is if we look at the standard rec, it was $275 worth of products being put on. The Agronomy 365 rec was $235, so we've already saved $40 just by accounting for those efficiencies. The Ferticast rec, which is what we looked at up here, actually goes into adding $53 worth of BW Fusion products. We're still down at $228 for that total application. So we're saving almost $50 just by accounting for our efficiencies and utilizing some of these products that can drive those efficiencies even further, building our ROI into our program. And this is another example of Ferticast. Goes in a little bit deeper, has some more commodity notes to talk about. You know, you need to add sulfur when you're bringing in your K because your pH is high to very high. So we're really trying to build efficiencies as a whole system. We're not trying to apply one nutrient just because we think we have a deficiency. Your K is not going to do you any good in a high pH situation if you're not trying to manage that as well. So through all these scenarios, we've seen that you can usually save some money on your fertilizer applications just by looking at your soil and how it can release nutrients for you through the year. So I hope you take a look at Agronomy 365 by BW Fusion and give us a call or visit us at our website at easycustomag.com. Thanks a lot, guys.